Now let's look at the topic of future value. Let's start with the following example. You make a $100 deposit in a bank today. The bank's annual interest rate is 10%. How much money will you have in your account at the end of the first year? In other words, you're asked to calculate the future value of today's $100 after 1 year at the annual interest rate of 10%. You can imagine a timeline where you mark 2 years. Year 0, which is today, and year 1 in the future. So between year 0 and year 1, we have 1 full year, 365 days. You deposit $100 in year 0, you wait 1 year, you earn the interest rate of 10% on your money, and we need to find the future value in 1 year. How do we solve this problem? You deposit $100 today. Money will grow to 100 plus interest, which is the same as $100 plus 10% of $100, which is the same as $100 plus $10, because 10% of $100 is $10. And $100 plus $10 gives you $110. This is the future value of today's $100 in 1 year. Let's think of a slightly more difficult problem. Again, you make a $100 deposit in the bank today. The bank's annual interest rate is 10%. How much money will you have in your account at the end of the second year? In other words, what is the future value of today's $100 after 2 years at the annual interest of 10%? So we have an extra year here. And again, you can imagine a timeline where year 0 is today. When we deposit $100, we wait 2 years, we earn a 10% annual interest rate on our deposit, and we are asked to find the future value in 2 years. So let's start calculating. During the first year, you earn interest on your $100 deposit. So 10% of $100 is $10. Over 2 years, you earn a total interest of $10 times 2 years equals $20. And so future value after 2 years is $100 that you deposit now plus $20 earned in total interest equals $120, right? No, this is actually wrong. Okay, what's going on here? What would be the right way to solve the problem? The correct calculations are as follows. You deposit $100 today in year 0. In year 1, you have $100 plus interest, which equals $100 plus 10% times $100, which equals $100 plus $10 in interest, which gives a total of $110. Then you leave $110 in the bank account. You don't withdraw anything, you don't add anything, you just leave it. We say that money gets reinvested for another year. So 1 more year goes by, that's the second year on our timeline, and what you will have at the end of the second year is $110 that you had at the beginning of the second year, plus interest, where interest is 10% of $110. That gives you $110 plus $11 in interest, and that adds up to $121. So $100 today, $110 in 1 year, that's the future value after 1 year, $121 in 2 years, that's the future value after 2 years. So notice what has happened here. You earned $10 in interest during the first year and $11 in interest during the second year. Where what is the extra $1? It's actually nothing but 10% interest on the $10 interest amount from the first year. So 10% of $10, which equals $1. And this is also what we call interest on interest. Let's look again at our calculations. Let's look more closely. Year 0, $100. Year 1, $110. Year 2, $121. Year 1, $110. How did we find it? It was found as $100 at the beginning of the first year plus 10% times $100. Mathematically, we can rewrite it. So in order to not repeat $100 twice, we factor it out. So we write it only once, and then we multiply by 1, which is what's left from $100, plus 10%, which is what's left from 10% times the second $100. Then let's look at year 2 result, $121. How did we find that again? We found it by taking $110 at the beginning of the second year and adding 10% to that number, 10% times $110. Again, let's rearrange it. Mathematically, this is the same thing as factoring out 110 because it appears 2 times. We don't want to repeat it. We write it once, 110, and then multiply by 1 plus 10%. But wait a second, what was 110 again? Let's look at year 1 calculations. 110 was nothing but 100 from the very beginning, year 0, multiplied by 1 plus 10%, right? And so basically we are expanding year 2 calculations a little bit by writing the very original $100 from year 0 multiplied by 1 plus 10% interest rate times 1 plus 10% interest rate one more time. And that can be shortened if we use power 2 for the parenthesis term, 1 plus 10%. Compare the results from year 1 and year 2, where we factored out $100. Don't they look similar? What's the difference? The difference is we have the second power for year 2 future value. Now, can you guess what year 3 future value will look like? That's right. You change the power to 3. Year 4 future value, the power will become 4. Year 5 future value, the power will equal 5, and so on. Now you saw the pattern, and now you can very easily calculate the future value of some given amount of money and interest rate per year for any year in the future. In general, to find the future value in T time periods, we take the initial amount that we start with and multiply it by 1 plus the interest rate for each time period raised to the power T. So why don't we use something simpler like annual rate, number of years? Because even though in this class we will mostly look at something happening every year, sometimes, like in real life, the frequency will be different. For example, monthly. For example, think about credit cards. You need to pay something for your balance every month. Think about home loans, car loans. We make loan payments monthly. What about rents? You pay rent on your apartment once a month. So there are actually a lot of monthly examples in real life. There are also daily and bi-weekly and all sorts of other frequencies. And not saying years, but instead time periods makes this formula more generalized. The initial amount can be called principal or principal amount. And then what it is multiplied by, 1 plus r to the power t, is also known as the future value factor. So essentially, it's like the connecting piece between how much you start with and how much you will have in the future. So you just multiply the initial amount by that number that this whole thing is equal to, that will get you to the future value. There's actually a table at the end of the textbook, table A1, appendix 1, which shows in columns different interest rates in increments of 1%, 1%, 2%, 3%, and so on. I think all the way to roughly 20%. I would need to check. And rows go from 1 to 2, 3, and so on, all the way, I believe, to 20, which indicate the number of time periods. So you can look up that table, find your combination of R and T, and that will give you the future value factor. The table will show you what the future value factor is. And then you can just plug it into the future value formula. But honestly, we can only use these tables maybe at home, maybe in class, but feel free to use at home if you like. But first, they're pretty limited because they don't give you the options with interest rates, between, say, 1% and 2%, like 1.5%. And for this reason, I'm not even using these tables in class, but just so you know, they're there at the end of the book if you want to try. Instead, I will be showing you formulas and the financial calculator. So we are going to look at the financial calculator steps in a couple of minutes. Now, if you're using the formula by hand, then one thing you should be careful about is how you use the interest rate in the formula, the lowercase r. Either in decimals. For example, if the interest rate is 10% per year, you'd put 0.1. Or instead, you can put 10%. Don't forget to press the percent button. But you should not just put 10. It's not gonna work. You will be way, way off. Then another term used when we talk about future value is money getting reinvested at the end of each year. You can also say that this is the interest gets compounded. The process we use in our calculations is called compounding. And the interest rate, which results in earning a larger amount of money in interest with each year, is known as compound interest, or a similar term is interest on interest. Just to review the example we just had, you start with $100. In 1 year, you still have 100, and you'll now have another $10 on top in interest. Then after 1 more year, you still have 100. You also earn a 10% interest on that, which is $10. And you also had the previous year's $10, and you earn 10% on $10, which is the extra $1. This extra $1 is the interest on interest. And notice how we don't have interest on interest until the second year. In the first year, we earn the first interest. As the name implies, interest on interest is additional dollar amount interest earned on the interest from the previous year. And things get even more complicated if we look further into the future, year 3, year 4, and so on.